Okay, I'll start by explaining how the user interface works for DMEX, and then I'll go deeper into how the smart contracts and the funds are managed. So we start from with basically the exchange view. I'm currently on the demo version of the exchange. You can see here a switch. You can switch from the live version to the demo version. It works absolutely the same, except the demo version runs on the testnet. So the Ethereum on the demo version is actually not real Ethereum. It's just a test version of Ethereum. So when people use the demo version, they actually don't risk any funds. So whenever a user first comes to DMEX, he is directed to the demo version and receives 100 ETH to the balance for testing purposes. Also on the demo version we run trading contests on which every month with a price, and the user who makes the biggest profit receives a prize. So on the left side of the screen we have the list of the tradable assets. So DMEX is a derivatives trading exchange, so we are talking about futures trading, and currently we offer only the cryptocurrency futures. So we have the assets from the crypto world: the Bitcoin, Ethereum, Litecoin, Ripple, Bitcoin Cash, Binance Coin, EOS, and so on. So from the left screen, the user can choose any asset that he wants to trade. So we go to the BTC. I'll make a test trade right now. On the right side of the screen we have the order book. The order book shows the current available orders, buy orders and sell orders. The bottom part is the buy orders and the top part is the sell orders. So whenever I make a trade, if I want to make it immediately, I will be hitting orders from the order book. So basically currently I can buy Bitcoin for $9,000 for $4.50. So to make an order, we use the order box up here. We have three types of orders: the market order, the limit order, and the stop limit order. I will show an example of the market order because it's the easiest. The market order will just buy or sell futures at the current available price. So I have the market order set. I have the expiration term for the contract is set to perpetual, so infinite, it will not expire. I have the price set to the market price. The leverage is at 2x, I can put it for instance at 10x, and then I can press one of these small percentages that will use a proportion of my balance as collateral. So if I put 25%, it will use 25 ETH, while I have like 100 ETH in my balance, so 25% would be 25. Okay, so I press the buy button. I receive the order confirmation pop-up. It shows me that it's a buy order. It shows me the amount. It's an approximate amount. The price is the market price. It shows the approximate order value and the margin used. And on the right side I have the estimated liquidation price. So whenever I open a position, depending on the leverage, I have a liquidation price for this position. The higher the leverage, the closer is the liquidation price, and the lower the leverage, the farther the liquidation price is from the entry price. Okay, so I press the sign order. You can see the order was created here and it instantly disappeared, and we have a position in the position table. So that's how market order works. Basically it executes immediately. So when we look at the position, we see, okay, the asset is the BTC, Bitcoin, the size of the position is 4.7 BTC, the value is $42,000 approximately, entry price is $9,008.92. Then we have the mark price. The mark price is the price from the reference exchange. So when trading futures, no actual underlying asset changes hands. Therefore, trading futures is basically trading contracts, and the price, the settlement price for the futures contract will be provided by a reference exchange. In this case, it's the Bitstamp exchange. So this mark price, if we go to Bitstamp, you will see that it is this is the mark price on Bitstamp, which is shown here in the mark price for the position. It is updated once every 10 seconds. Here is my liquidation price. The leverage is 10x as I have set it to be. And here in the unrealized profit column, I have the profit or loss for the position. At this point, based on the mark price from Bitstamp, my profit is 0.23 ETH. So I can keep the position open for as long as I want, or I can just close it at any point. I just can press the close button and just sign the order, and it will execute into the other direction. Now I'll have to wait for a minute for the balance to update on the blockchain, because every transaction is actually recorded on the blockchain, and it takes like 14 seconds for a block to be mined. So now you can see the balance has updated. So I made a small profit on this. So if I go to the transaction history tab, I have the list of all transactions. So when I place an order, multiple trades can occur, because it will go through many orders if one order is not enough. All trades are recorded on the blockchain. So Etherscan is the block explorer for the Ethereum blockchain, and this is the transaction. So every trade I make is recorded on the blockchain. This is the contract address for the trading contract address that records all the trades. And we can see in the event logs that we have several events happening, which the futures trade event is actually the event when a trade occurs. So it's basically, at the end of the day, the user experience is pretty simple. You just choose an asset, and you just have two buttons from buy and sell, and you also some settings like the leverage and the expiration term for the trade, for the position. This is basically basically how it works. So the difference between DMEX and other solutions, and let me show let's look at BitMEX, which is the biggest player on the derivatives, on the crypto derivatives market. You can see they have a spike in the volumes of 4.3 billion last 24 hours. Go to live trading. So it's basically the same system. It works in exactly the same manner. The big difference being the decentralization part, because BitMEX is a centralized exchange. It means that all funds are stored in a wallet that is controlled by the owners of BitMEX. So that wallet gives the operators of BitMEX gives power over users in the sense that they can lock your account, they can freeze your funds, they can refuse to withdraw, to perform your withdrawals, and they can simply get hacked if at some point and lose all the customer funds. So while you are trading on BitMEX, you're actually giving away the custody of your funds. And you have to trust the BitMEX owners, the company, to not mishandle your funds. Well, DMEX performs the same operations in terms of trading and the user experience as BitMEX, but the funds are never in the custody of the owners of DMEX, because all funds are stored on a smart contract. And then now I will explain the smart contract part works. So we go to the smart contracts list. We have 3 smart contracts. The first smart contract is the base contract. It holds all the funds. The futures contract is actually the trading contract. The trades are recorded in the futures contract. The futures contract calls the base contract to change user balances. And the Oracle smart contract is just the contract that is communicating with the Oracle to bring in the price. So when futures contract is settled on DMEX, it has to be settled by the price from the reference exchange. So the price is provided by this Oracle, by decentralized Oracle, which means that we cannot trick the system. So the owners of DMEX cannot provide the price for settlement and then put a bad price and mislead users. So in terms of custody, we go to the base contract, the custody contract, and we are now on the testnet. And just to remind you, it's a demo version. It's the same on the live version, doesn't matter, but it's absolutely identical contracts. So when we look at the base contract, first thing I will show is the points of entry of funds. So in Solidity, in Ethereum smart contracts, when you the smart contract will only accept funds through a payable function. So if you send funds to the contract, simply to the DMEX contract, the transaction will fail. You have to call a specific function, a deposit function on the contract to actually get the funds inside the contract. And these functions are these 2 functions. So we have the deposit function, and we are talking about ETH right now. So we have the deposit function, and you see the word payable next to the function. And we have the deposit for user function, which also has the keyword payable next to it. I'll just show that there is no other function with this word. So basically, you can see that only these 2 functions. This means that that you can deposit funds to the DMEX smart contract only through one of these 2 functions. So let's look what these functions actually do. So we see it, first of all, it verifies if the contract is not destroyed, and the contract can be destroyed if there's a new contract deployed. The old contract is marked as destroyed, so people cannot send funds to it. And then what it is doing is adding balance to the user who sent the ETH. So it uses the add balance function. It calls the add balance function. Address 0 is the address of the ETH token, and message sender is the user who sent the funds to DMEX. So when you send funds from your wallet to DMEX, the funds, for instance, you send 1 ETH, this ETH will be stored in your balance on the smart contract. It will be assigned to your wallet. So only you can control those funds. And message value is the actual value of ETH sent to the function. It goes on to set some variables which are necessary for other things, but we will concentrate on this for the time being. So add balance function adds the balance to the person who sends the money, sends the funds. That's it. So deposit for user function does the same thing, but it also accepts a destination user for destination address for the fund. So in this case, the balance is added not to the sender, the address that called this function, but to the user provided provided as an argument to the function as a parameter. So this is the only way to get funds in. There's no other way. So if you send the ETH to the DMEX contract without calling this function, the transaction fails. And in Ethereum, when the transaction fails, it will cancel any operation on the smart contract. So if a transaction is failed, it makes absolutely no change in the contract. So these are the only 2 points of entry. Now we see that they use the add balance function. We can go on and check this function, what the function does, how it works. So you can see that this function is calling another function, which is an add balance function. So what it simply does, it just increases the balance of the user. You can see it uses the update balance function method. Here it is. And it's a bit complicated here. It's a bitwise operation, but it basically encodes the information into the balance. Okay, this is the part of this is the deposit part. So in order to get the funds out of the contract, you have to use one of the withdraw functions available. So we have this. This is the withdraw function. So this function can be called manually on the contract by anyone. It's not restricted, it's public. So you just call the function from your wallet and you say I want to, what sort of which token you want to withdraw and the amount. Then the function verifies that you have the available balance. The message sender is the wallet that sent the request for withdrawal. If the amount is not sufficient, it will throw an error. Again, if an error is fraud, the whole transaction fails and no changes are made on the smart contract. So after the contract verifies that you have enough funds, and available balance is actually the total balance minus the reserved funds. So the reserved funds is whenever you open a position, you provide collateral, the margin, and this margin is reserved on the account and cannot be withdrawn until the position is closed. So the available balance of function will actually verify if there is enough not reserved balance to withdraw. And if it's enough, it will subtract the amount from your balance, and then it will actually send the amount to your wallet. And again, if something goes wrong, the transaction will be canceled. You cannot take out more than you have, or you cannot take out funds from a different user. So this is one function which can be used by calling the contract directly. It's more like an API sort of thing. And there is another function which is called admin withdraw. And admin withdraw allows to initiate withdrawals from our server on the behalf of the user. But in order to make a withdrawal, we need to provide a signature from the user. So this function is used for the user interface. So when a user tries to withdraw funds from the user interface, he will be asked to provide a signature for the withdrawal, and the signature will include the amount the user wants to withdraw. And again, the same operations will happen. The contract will verify that there is available balance on the user's account. Will subtract the balance, subtract the fee, which is the gas fee to record the transaction, and will perform the same operation. So security-wise, holding funds on the DMEX smart contract is as safe as holding them on your own wallet, because the contract will only perform operations that are explicitly approved by the user by providing a signature. So either providing the signature to use through the admin withdraw function, or calling the contract directly through the withdraw function, in which case you don't need a signature, because the sender is the owner of the funds, the message sender, the initiator of the transaction. Next we go to the futures contract, the trading contract. The main function in this contract is actually the trading function, which performs the trade. I'll show it now. This is the futures trade function. What it receives is it receives two orders. It's a maker order and a taker order, depending on who was first in the order book. And So basically, these are two orders from two users, and from each order has an order hash, which is basically generated from the parameters of the order. So every order is unique, and then after the order hash is generated, the function also receives the signatures from the user, so it will verify that the order was actually signed by the user. So if there is no signature, it means the user has not allowed for this order, did not create this order. So once we make all the checks, we check that the signatures are correct, we check that the users have enough funds on their account to cover the collaterals. We check that the quantity is correct. And if, for instance, you send two orders and one is bigger than the other, the minimum quantity between two orders will be executed. It's a bit technical here, but basically it does mathematical calculations and records them on the user balances. So it would be easier to visualize DMEX and a smart contract as an Excel file, which has the balances of each account. So you would have a column with user wallet addresses, and their total balance and the reserved balance, and then you would have a table with the positions where user positions, the active position would be recorded, and this is sort of everything that happens here. This smart contract also is used to settle positions once they are expired, and liquidate position if the liquidation price is hit. When a position is liquidated, it also uses the price from the reference exchange, so the mark price, not the internal price on DMEX. Now let me explain you about the token. So in order to make this the token concept actually work on DMEX, and to make it make sense actually and be decentralized, we have employed the following methodology. So basically the initial goal was to make sort of a revenue share. So basically we issue a token, and according to the number of tokens users have, they receive access to the proportional amount of the fees, of the trading fees collected by DMEX. That would imply having a smart contract which would basically take the fees from DMEX and divide them in the correct proportions and send them to the wallets of token holders. Well, this is technically not possible because there are limits to how much information you can perform in one transaction. So if there would be like many token holders, like 100 or 1000, it would be impossible to process in one single transaction, and then it would be necessary to create multiple transactions, and this would affect the decentralization part, because if there would be multiple transactions, somebody would have to operate this process of dividing the fees between accounts and so on. So we employed, because this is technically not possible, we have employed a different approach to it. So the logic is as follows. All the fees from the DMEX, in the DMEX smart contract, the futures trading contract, an address is set up to collect the fees. So there is a wallet address inside the contract that collects the fees, all trading fees. I will show you. So if we put read the contract, we will find here, you see the fee account. So this is the account that it is actually an Ethereum account that collects all the fees. So the token structure is as follows. This fee account is going to be replaced by the token by the token address, because token has also a smart contract. Is also a smart contract and has an address on the Ethereum blockchain. All the funds collected into the fee account are then withdrawn by the token contract and divided into two shares, 38% and 62%. I'll show you the this is the actual token contract on the mainnet. So inside the token contract, you can see here we have the operational percent and the buyback percent. So the operational percent 62%, roughly 61.8, and 38.2% buyback percent. So what happens here? 62% of fees that are extracted from DMEX go to an operational wallet to pay for servers, for marketing, for gas fees, and so on, for all the expenses, the operating expenses. And the other 38%, 38.2%, is transferred to the token holders, but it is transferred indirectly. It is basically used to buy back tokens from token holders. So if we go into this extract fees from DMEX function, this is the function that actually takes out the fees from the DMEX smart contract. So first of all, it gets the available balance from the DMEX base contract. It takes the available balance for the recorded token, and it takes the DMEX and it calls DMEX to withdraw the funds. So basically, it checks how much tokens there are on the contract and withdraws all of them. So it takes the fees from the ETH value of the fees collected from DMEX and multiplies it by the buyback percent, and the operational value is basically the total value minus the buyback value. So the buyback value is used to purchase back DMEX tokens through the Uniswap exchange. So it calls the Uniswap. DMEX tokens have their own Uniswap exchange, and it's a decentralized exchange. And this contract basically buys back available tokens for sale in this Uniswap exchange. And the important thing is that after it buys the token, it will burn all the tokens bought, which means that the total supply of tokens, the number of tokens in circulation, is constantly decreasing. So the interesting thing about the DMEX token is that it basically has a guaranteed buyer in the form of DMEX. So the better DMEX is doing, the better the more the bigger the buyer, because the more fees is collected by DMEX, the more Ethereum is then spent on buying tokens. And the second important thing is that the amount of tokens is decreasing with every purchase. So the supply is constantly decreasing. So this is a sort of a workaround in order to overcome this technical impossibility of just sending fees to token holders. The token holders are actually benefiting from the value of the token. So the token holder will not actually receive fees, but the token holder is able to sell the token at a future value. So the benefit of the token holder comes from the increasing value of the token. That's it. So let me explain it again in a more simple terms. The token, the DMEX token, is limited to 1 billion. It's the initial supply. It's actually smaller already, but the initial supply was 1 billion tokens. And this supply will be constantly decreasing with every purchase. So if we assume that at least somebody will use DMEX, then that person will pay fees, and these fees will be used to buy the token back from the token holder. if we assume that DMEX will be growing and will have more success, well, the more tokens will be bought at higher prices and burned as well. So that's how it works. So I'll explain a bit how DMEX, the stage of DMEX. So DMEX is basically now at like, it's basically a live product. We have solved an extremely big amount of bugs already, so problems appear less often. If when we started developing it, we had problems every day, multiple problems every day, not everything working and so on. Now we have like problems maybe once every 2 weeks, sort of bugs appearing, and then we solve them, and the same bug will not appear again. And so it's basically, it's not an MVP, it's not an idea, it's a live product, it's already live. It just needs right now an investment in marketing so we can attract more traders. Also, I'd like to say some words about the security part. So when you use DMEX, you use actually the wallet, your Ethereum wallet, to trade and to deposit funds. And you have several options of how you can do that. You can either enter your private key. So basically you would go and say, okay, I want to connect a new wallet, and you would just enter the wallet address and the private key, and then you can use it. Well, the private key will only stay in your browser. It will not be sent to our servers. So it's just stored in your browser cache, and if you just delete the cache, the wallet will delete. So if your computer is secure, you can use this method. If for added security, you can also use a MetaMask extension, which is basically so now I'm connected to DMEX through my MetaMask extension, and the MetaMask extension is actually an extension in the browser, and it holds the private key. So the private key is not inside the DMEX application, but inside the MetaMask extension. So in this case, when I try to trade, when I make a trade, I want to test that. That's Meta for now. So when I make a trade using MetaMask, when I say I want to sign an order, a pop-up appears like this. It's from MetaMask and says, asks me to confirm to sign the message. So I press the sign message, and it transfers the signed message to the application to the application, and the application then sends it to the server, the signed message. So the private key is never actually leaving this extension, this MetaMask extension. Now, I can also, for even more security, I can use, here again, when I close Node, I have to sign it again. So for added security, I can use a USB drive like Ledger, which is a hardware wallet. I'll show you now how it works. So I go to connect, I go to the ledger parts. I'm waiting for it to give me the addresses. Okay, so it gives me the available wallets on my ledger USB stick. Okay, so now you can see that now I'm accessing DMEX through ledger and connected with my ledger. So now when I want to place an order, I will repeat again the order, place the signed order. I have now on the ledger, on the actual ledger, the USB stick, I have a message on the screen that asks me to sign a message. So I confirm the message on the ledger, and you can see the order goes through. So this is the most secure way to use DMEX, because the private keys then are stored only on your USB stick, and they never leave the USB stick. So fully safe. I can close the order again. It will ask me to confirm the signature again on my ledger. I confirm it now. That's it. And so that's basically how it works. I can tell a few words about the other order types. We have the limit order. On the limit order, it works, you set up the price. So for instance, this is the limit order, and I set a little bit, a smaller price. I sign it from my ledger. So you can see this order with orange mark. This is my order that appeared in the order book. Okay, have some bugs. So if I want to cancel the order, I say cancel. Again, I have to sign from my ledger, and I cancel the order. The stop limit order is the same as the limit order, but it also has a stop price. So it's a more advanced order. Let's say. Let's leave it at that. It's more information is available on in the docs. So for now, DMEX allows two margin currencies or collateral currencies. It's either ETH or DAI, and DAI is a stable coin which is equal to $1. So basically, it's pegged 1-to-1 for dollars. So basically, if you don't want to deal with the volatility of Ethereum, of ETH, you can use DAI, and then you sort of can trade basically using dollars as collateral. And we are working on some solutions to bring Bitcoin as well, so in a decentralized way. So we are looking forward maybe in the next couple of months to have Bitcoin as well, which will also increase our potential market share.